Stanley B. Prusiner's contributions to neurodegenerative research. In this presentation, I will discuss Dr. Prusiner's discovery of prions. By going through his history, background, and past and present research, I present Dr. Prusiner favorably to enlighten the public on his positive scientific impacts. I discuss his discoveries, the pushback he received after announcing the name and definition of prions, and his supporters and the evolution of the acceptance of the prion concept. To scientific investigation that creates new knowledge, erases ignorance, eradicates prejudice, prevents disease, alleviates suffering, and enhances well-being. That was a quote from 1997 Nobel laureate Stanley Prusiner from his 2014 book, Madness in Memory. Stanley B. Prusiner is a distinguished neurologist and biochemist. His long-term research in neurodegenerative diseases has advanced scientific knowledge of diseases like Creutzfeldt-Jakob disease, CJD, Alzheimer's disease, and Parkinson's disease. Prusiner and colleagues have studied and are currently studying causes, biologies of, and treatments for fatal neurodegenerative diseases. Prior to studying neurology and infectious diseases, Prusiner studied Latin, philosophy, history of architecture, economics, and Russian history, to name a few topics. His familial background likely inspired these subjects. His paternal grandfather immigrated to Sioux City, Iowa, United States from Moscow, Russia, as a young child. His father and grandfather resided there among a tight-knit community of Russian Jewish immigrants. After a career with the U.S. Naval, his father moved Prusiner and his mother from Des Moines, Iowa to Cincinnati, Ohio, where he worked as an architect. Prusiner completed a BA in chemistry and an MD from the University of Pennsylvania, where he also researched hypothermia with Sidney Wolfson in the Department of Surgery. Additionally, Prusiner studied adipocytes or adipose tissue with Britton Chance, a pioneer in biomedical optics research, and Olav Lindberg of the Wenner-Gren Institute in Stockholm. Soon after, he worked for the National Institute of Health, NIH, under Earl Statman, studying glutaminase and E. coli. Prusiner's 3 years as a lieutenant commander in the U.S. Public Health Service at the NIH developed his research skills and set him on the path of a neurology residency. In 1972, Prusiner was a neurology resident at the University of California, San Francisco, UCSF. Here, he encountered a patient dying after just 2 months of becoming ill of CJD. Her brain degenerated rapidly while her body stayed intact, unaffected by the disease. Prusiner reported that the patient experienced no fever response, no increase in white blood cells or cell count, and no antibody protection or humoral immune response. The results of Prusiner's patient discourse sparked his interest in neurodegenerative diseases and led to his discovery of prions, proteinaceous infectious particles, or proteins with no nucleic acid. Prions are infectious pathogens that cause fatal neurodegenerative diseases, which can present as genetic, infectious, or sporadic disorders such as CJD. All mammals have protein cells. Prion diseases modify the prion protein. Prusiner's concept of the prion can explain how heritable diseases can also be infectious and defines how the prion protein modifies. However, Prusiner did not discover prions without barriers. Studying neurodegenerative diseases, scrapie agents, and assays in mice and hamsters takes many years, the incubation periods for these diseases being 2 years or longer. The laboratory studies not only take long periods of time to complete, they are also costly. Multiple funding programs, including the NIH, have assisted Prusiner's research. The more he studied scrapie anticipating a virus, the more he discovered that the protein was devoid of nucleic acids, a key component in viruses. As the data accumulated, Prusiner became increasingly confident that he had discovered something unique about neurodegenerative diseases. After publishing his first article introducing his hypothesis naming prions, a windstorm of backlash came at him. Claiming that prions can spread infection without deoxyribonucleic acid DNA or ribonucleic acid RNA went against a central dogma of biology that DNA was essential for all reproduction. His definition and theory were scientific heresy in the community. Although skeptics not only tried to disprove his theories using scientific methods, but also attempted to viciously attack Prusiner personally, he continued researching prions and their modifications. With the support of his family and a team of colleagues, he overcame the controversy and continued crucial scientific work that had not been done before. By the early 1990s, Prusiner, Leroy Hood, Stephen D'Armond, and Ruth Gabizon, among others, had all contributed to the acceptance of the prion theories. Although there were still gray areas, for instance, what specifically caused normal prion protein to convert into its disease-causing form, Prusiner had advanced scientific knowledge of this malicious pathogen tenfold. For his many years of efforts, prions became more widely accepted among scientists, and he won many scientific awards, including the Nobel Prize in Physiology or Medicine 1997. No one could describe Prusiner's arduous journey as well as he has in his own book, Madness and Memory, The Discovery of Prions, a new biological principle of disease, a first-person account of the thinking, the experiments, and the surrounding events that led to the identification of prions. Since discovering the intricacies of prions and their ability to misfold healthy proteins into diseased cells, Prusiner and colleagues have discovered that prions not only affect CJD, Kuru, and Scrapie, but also play an essential role in other neurodegenerative diseases, such as Parkinson's disease and Alzheimer's disease. Prusiner's concepts and research have been at the forefront of health discussions, including the long-running international health issue of mad cow disease from 1986 to 2012. He is still at the head of health discussions while researching treatment for other degenerative nervous system diseases in partnership with Alzion Incorporated. Alzion is a biopharmaceutical company focused on developing new medicines for patients suffering from Alzheimer's disease and other neurological and psychiatric disorders. Most recently, Alzion is testing ALZ-801, an orally administered medication that could potentially be the first disease-modifying treatment for Alzheimer's disease. As Guy McCann observes in his review of Prusiner's book, Prusiner has again steered research and opinion to an undiscovered realm of neurodegenerative diseases, despite battling consistent skepticism and criticism. The Bright Focus Foundation, a prominent research-funding nonprofit organization, says Dr. Prusiner's research may one day lead to a treatment and cure for Alzheimer's and possibly even more neurodegenerative diseases. Prusiner has voiced many thanks to Bright Focus and all other funding programs for presenting the opportunities he's needed to propel science forward. After submitting his landmark article to Science and before it was published, Prusiner presented his findings briefly at the 5th International Congress of Virology in Strasbourg, France. Although he did not dare name prions, he would wait until after his article was published. He broke the news of his infectious proteinaceous particle, and he was met with disbelief and hostility. Questions arose ranging from predictable, how can a virus be only protein, and how can it be devoid of nucleic acid, to deeming Prusiner inept. How can anyone who calls himself a scientist not find a nucleic acid core, or finding evidence for a nucleic acid is easy, you must have done something wrong. Despite his many years of devout research, his team of highly esteemed experts, and his conclusive evidence, scientific critics and common folk skeptics alike refused to acknowledge the brilliance of Prusiner's findings. Prusiner battled a long wait and editor tirades before Science published the article as had been promised. The push came when former UCSF Chancellor Frank Soy asked them to allow David Perlman, a reporter for the San Francisco Chronicle, early access to Prusiner's article. Perlman published his story talking about a weird new form of life that Prusiner discovered while giving few details. The pressure was put on Science to finally publish Prusiner's article, despite their fear of causing commotion and disruption, which, as previously mentioned, is exactly what happened. While developing his theories, Prusiner acknowledged the previous academic work on diseases like CJD and Kuru by scientists such as Bill Hadlow, C. Joseph Gibbs, and D. Carlton Gajuzak. But still, critics refused to believe that there were no nucleic acids present. Despite having presented years of research and findings that separated viruses from Scrapie agents and breaking ground in neurodegenerative disease knowledge, Prusiner was described as impulsive, presumptuous, reckless, ambitious, aggressive, callous, manipulative, and even egotistical. In reality, he was a determined scientist and investigator who had taken an interest in truly helping treat and cure fast-working and fatal diseases of the brain. The scientific community had the right to be skeptical of such a bold claim. They do not experience breakthroughs and big new ideas often. However, no matter where Prusiner went, whether it be a lecture, press conference, or interview, he faced considerable pushback against his evidence and claims. Each conversation tended to repeat arguments he had already made and continue down an unproductive path. Despite him and his family, especially his wife, becoming increasingly stressed with the negative media coverage, Prusiner remained objective and resolute. He and the colleagues who supported his efforts continued to produce vital research and evidence that a virus was not the cause of scrapie and CJD. Even after working closely with Ted Diener, who discovered viroids, small, highly infectious RNAs, using the viroids as a control and concluding that prions were not viruses nor viroids, the debate rampaged on. Their published work in Proceedings of the National Academy of Sciences, Viroids, Viroids and Prions, did not allay critics' suspicions that scrapie was caused by a virus with small nucleic acid. Prusiner and his research team spent years thereafter continuing to search for the mythical nucleic acid of the prion, occasionally finding some evidence for it and subsequently debunking the finding with further examinations and tests. If there were nucleic acids to be found, Prusiner would be the one to find it and continue from there. However, none were found, and he has been able to continue his prion research to date. While asking himself why there was such resistance to his concepts, Prusiner thought back to 1944, when Oswald Avery, Colin MacLeod, and Macklin McCarty discovered evidence that DNA composed a transforming principle. It had taken 75 years from Friedrich Miser's isolation of DNA for those three distinguished investigators to confirm their findings. It then took over a decade for nucleic acid to be accepted as genetic material. Relating the controversy and slow acceptance of DNA to his own concepts of prions, Prusiner quotes Belgian playwright Maurice Maeterlinck. At every crossway on the road that leads to the future, tradition has placed against each of us 10,000 men to guard the past. During his long-term joust with the press, Prusiner experienced a problem that exists with all media coverage, especially in scientific and academic communities. The more he talked to them, the less likely it was that the truth would spread about his hard work and incredible findings. His intention to inform the general public of new research discoveries in his field by speaking to interested reporters had morphed into him feeling betrayed and hopeless. Thankfully, the derogative attacks on Prusiner's character and research ironically belied the support he gained from scientists in and out of the scrapie field. Prusiner decided not to discuss his science with the press any longer so as not to cause conjecture and speculation that were of no value to the real progress he was making in his field, and instead continued to produce data and let the published record in refereed scientific journals speak for itself. So he let the critics stay stuck in one little framework, as neurologist Douglas J. Langska put it in his interview with Prusiner, while Prusiner continued to work toward bigger and better ideas. Prusiner was not solely contested. He encouraged many strong scientists, researchers, and academics who supported and continue to support his work. Langska is one of these people. Langska and Lauren E. Klafke's private and public interview with Prusiner in Boston for the American Academy of Neurology Oral History Project encapsulates the support he had. These three had genuine chemistry that portrayed the truths behind Prusiner's background, research, and the battle he has fought to be recognized as having an earnest and profound scientific discovery. Apart from his struggles, they discussed a wide range of topics, including a friendly mention of Prusiner's trip to the South Sandwich Islands. There, he visited Prion Island, home of the prion bird, the main competitor of Prusiner's name choice for prions. They discussed the aforementioned opportunities Wolfson, Chance, and others granted Prusiner, opportunities that changed Prusiner's life from one with no real direction or desire to one packed full of ambition to solve problems and help people along the way. Prusiner was never interested in becoming a billionaire or acquiring fame. He was only interested in doing research and living a healthy life, spending his time attempting to allow others the chance to live healthy lives. As Langska observed, since discovering what he wanted to accomplish, Prusiner focused on and refused to stray from his concepts. He pulled colleagues in, built collaborations, solved problems like nobody's business, and succeeded in accomplishing something that seemed impossible to accomplish. Prusiner dedicates his successful career to his plentiful opportunities and to wonderful luck. Prusiner is a man full of gratitude and appreciation for a life well led. He has put his skills and knowledge to the forefront of neurodegenerative brain disease cures and treatments and will continue his groundbreaking research until he can no longer. As the scientific community has come slowly around to, for the most part, accepting Prusiner's evidence concept of prions, so has the general public. The world is a better place because of Stanley B. Prusiner's revolutionary ideas. In this presentation, I discussed Dr. Stanley Prusiner's academic background, past and present research, as well as his discovery of prions. I covered the pushback Prusiner received after announcing the name and definition of prions and the evolution of the acceptance in the prion concept. Thank you very much for this opportunity.